Hi everyone, I wanted to go over templates. I don't particularly like how I described them in the previous recorded videos. So let's get going on that. So what we're going to actually see templates a lot more very soon when we look at the standard template library. It's right there in the name even. The T. So a template allows us to store data, store different types of objects in a particular class. So if I have a linked list that's a templated version of linked list, which I will actually do, I'm not thrilled with how the code ended up looking. It's a little bit more convoluted than it should be. But if I'm trying to make a linked list with a templated version of a linked list, it means I can store almost anything in that linked list. That's sort of the point. As long as it adheres to certain specifics about what type of data it is, templating allows me to do this. Now, a lot of languages have this. C++ got it late in the game, and it sort of looks like it. It's sort of a bit clunky compared to other languages, but let's go over what we're doing here. So we're going to be able to store a whole bunch of different data. So for like my dynamic linking link library data, which was a struct with an int, or I could make an object with an int, or make an object that holds a string. Whatever the case is, as long as it adheres to what my linked list or my linked list nodes are actually calling, the functions it's calling, then I can store it in there. That's the idea of a template, that I don't make a linked list class for integers and then make a linked list class for strings and then make another one for whatever the case is. I want to make a linked list class and take a whole bunch of different things. If I have a sorting algorithm, it can sort a whole bunch of different things. As long as it can do, in the case of sorting, as long as it can do the greater than operator, it can compare two things and say which one should go before the other one. That's good enough. And so we're all this like adding, removing nodes. We want to be able to do it once correctly and pretty much not have to rewrite it again. This is what we call a template class, or you could say it's a class template. The idea is, in fact, the class doesn't actually exist yet. We write this syntax, say this is the blueprint, this is what it should look like. Anything that's going to be stored in this linked list has to adhere to this blueprint. And then here's the weird thing, and I'm getting ahead of myself here. As soon as I have an instance of that, so if I have a function that's templated and it takes in a data type T, if it can accept that data type T, whatever that T ends up being, it'll make a brand new function. Each time I try and put something different into that function, as long as it's allowed, it'll make a brand new version of that function without you knowing. Under the hood, like before it compiles and it gets saved as a binary file, it'll actually make a new version of that function for every instance, every type of new data that comes along. That's what's kind of wonky about templates. So, and the other weird thing, or at least the thing that I find weird, I'm sure there's probably some other workaround, but honestly, I haven't found it, and I'm too lazy to find it because, quite frankly, this is not a huge part of the course. It can come up on an exam, but it wouldn't be a major component of the exam. Right now, if I want to make a templated class, a class template, I would need to put everything in the .h file. Now, it said put everything in the header file. We put everything in the header file, or you can also put it in the CPP file, but I just put you got to put everything in the header file essentially, which makes things a little bit wonky. We'll see a code example, several code examples of this. The live coding that I do after this, which I've already done, it's a bit long-winded, but I think it covers what we're talking about, which is instead of having a .cpp and a .h file, I put the definitions of these functions in the .h file. And then from there, I change it so that it's templated. Everything is in one file because it's the only way it'll actually work, because I'm generating a new file, a new class each time. We create the right kind of classes during compilation. So I will make a class, a linked list class with a string, and it will make it during compilation. I'll make a linked list class that stores I don't know, student information, and it'll make a brand new class, linked list class on when I compile. Every single time I make a new linked list with a different type of data, it'll make a brand new set of classes for me. That's what's kind of weird about this. Okay, which is why it all has to be in the header file. Here is actually our syntax. So what we have here, I think I have a better example of this. The big one is I start off at the top line before my class. I say template, type name, and then whatever I'm going to call it. By convention, typically this is saying no type, but really I'm typically putting a T in there. Why? Because I'm lazy, right? It's a template. So what's the shortest thing I can write? T for template, right? It's just a convention to say I don't have it named yet. It's not a class. It's not something defined. It's just something. I'm going to get to it later. It's an IOU. IOU, one class that goes in there that matches these criteria. So in this case, I'm making, in this example would be making a linked list class. This is saying, by the way, I need to know about this other class, the list class. And then for each node, it's going to be a templated node class. And here's my friend class. It is my linked list friend class. In public, I have a node, and oh wait, it takes in a node type, the type of information that we're dealing with. So it's a node that takes in a string, or it's a node that takes in an integer. And notice my actual definition of the methods are right there in the class. So by the way, I'm using the parent constructors, and here's my constructor at the end. My definition of my constructor is in the curly braces. Here's get data from my node. It returns the data, and the data is of this type, T or node type or whatever we want to call it. And my next is a node of type node type. What you'll notice is when we're looking at the code, every single time I deal with a node or a linked list or anything that's templated, every single time I put the type of data it is behind it. So if it's a linked list that takes in a data type T, then each node takes in a type T. And every time I say node, it'll have that T in there. So this allows you to, this is announced you will use node type as this generic class, and it's going to be replaced later. It's an IOU, one generic class, something that will fit into this. So it is saying, I'm trying to think of a really good example here, right? This thing can support, what would be a really good example? I don't have a really great example, but let's try it. I have cookie scoops. I'm just coming up to the top of my head here. I have cookie scoops. What are they used for? Well, it can make a regular sized cookie about this big. You can also use it to make meatballs. You can use it to scoop ice cream. Doesn't matter, but it makes a cookie about this size. The cookie scoop doesn't tell you what's going to go in the cookie scoop. It just says this is about the size it's going to make. Whatever you put in there, it's about this big. It tells you the requirements. It gives you a set of constraints on what you can put in there, but it doesn't actually say what goes in there. It just says, by the way, and we'll need a cookie scoop that's something this big. I'm not going to say what's going to go in it. It's just this big. So everywhere I had node type, I put node type, node type, node type, node type, or T. Before, what I had in the earlier examples, if you looked at the slides earlier, I had a char star, but it could be anything. It doesn't have to be a char star. As long as it matches the kind of function calls I'm going to be making, I can put it in there. And this is actually needed. This is the for declaration saying, by the way, I'm going to need a friend class of node class named list, and it's going to take in a node type as well. So here would be my node type again, another version of it. I have a constructor, a destructor. This is my list class, by the way. This is just another version of it. And again, it takes in type, node type. So what goes in? Node type. Insert at the back, node type. I have to keep on putting that in. It's the stuff that's going into my function calls. And then finally, I have a particular node type here. There you go. My constructor itself. So we need to write a template line before each function. Especially if I'm doing a function version of it, I can make a templated function and it will take in a particular types of data. So before each function, I can indicate the use of a node type template before the variable type name used. I think I have an example of that, do I? No, I don't. So one example might be, let me see here. Bool compare, and I want to say let's say I have some generic function that is going to compare var1 and var2. Well, I would have the same sort of thing. I'd have so my function, and I can have something like so if I have this, what do I need? Anything that's going to go in there has to have this operator involved. It has to have the greater than sign. So I could put two integers in here. I can put objects in here as long as they've implemented the greater than operator. I could, or if I had checking to see if these two things are equal, as long as I've implemented the equals operator, it's fine. So it will take in anything as long as when I use that variable, all the different function calls on that variable type are implemented. We'll look at this again very, very shortly. You're going to look at it in terms of live code now, but very, very shortly we'll see this when it comes to sorting algorithms. It will take in any kind of data type that you want, any kind of thing that handles an iterator, so that can walk from one element to the next, and perhaps more importantly, any of the elements you need to be able to see if one is less than the other one. That's all you need. So I can sort strings, I can sort integers, I can sort objects. As long as I have the less than operator defined for any of these data types, it can be stored in these kinds of structures and sorted. That's why we have templated data types. But it gets really kind of wonky in terms of the syntax. So hopefully the next live example you're going to see is going to clarify this, but if it doesn't, well, I can do it in the live demo with an easier example, hopefully. All right. You'll also be potentially trying to do a templated version of hash table, which would be probably very good practice for you. Okay. So just as a quick review of what we've been looking at, we looked at linked lists. We looked at being able to insert beginning, middle, and end of a linked list. And to insert at the middle, the right way of doing it is to use an iterator, meaning I don't know what kind of data is actually stored in my linked list. I don't want to know how it's stored. I don't want to know that there's nodes. I want some kind of iterator, something that, like at my finger, where I can, if I'm reading a piece of text, I move my finger along, and that's pointing to where I'm reading next. An iterator, I don't need to know what I'm pointing to. I just need to be able to move my finger and address where I'm pointing to at the time. Okay, so we've looked at simple linked lists. We've looked at double linked lists, which use inheritance and polymorphism. We didn't do circular linked lists, but you can definitely implement those things. It means that the very first element points all over to the end, and the end element points to the very beginning one. And now you need a way of knowing when you went back to the starting position. Iterator is very useful for that because you can get the start or the beginning. And we looked at a templated linked list where we're going to see that's more in action very, very soon with an iterator. Okay, with that, I'm going to stop the video, and then we're going to pick up standard template libraries very, very soon. Okay, thanks.